Module 3, Topic 2. Let's start this thing. Lesson 1 is ready for you. Have a highlighter, have a pen, pencil, etc. stuff to write with. And then also find the self-reflection document, because I want to highlight that along the way, you should be reflecting on what you're learning. And we're going to specifically talk about, in this next section of videos for Lesson 1, these two I can statements, naming the sides of right triangles in terms of a reference angle, and developing the relationship between the side length ratios and the reference angle. So a key word in this self-reflection document is the reference angle, as well as the fact that we're talking about right triangles. That's what trigonometry is all about. Back on page 535, let's go ahead and highlight those vocabulary words. Our key terms, the first one. In fact, I'm going to bring in another pen and highlight or star the term reference angle, because this is the most important thing to identify when we begin these problems. You have to know your center, your origin, and that's what this is. We're going to talk about in the next set of videos, like I mentioned here in these two self-reflection statements, we're going to explore trigonometric ratios as measurement conversions, and then we're going to analyze the properties of similar right triangles. Let's talk about the review. How many centimeters are in a meter? If you didn't know, centi means 100. Like in Rome, they had units of soldiers that were broken up by centuries. Centurion, a century is 100 years. So I guess, let's just see what Siri says. Hey Siri, how many centimeters are in a meter?
1 meter is 100 centimeters.
Okay. I'm going to say it the way that Siri did, maybe a little backwards. So if how many centimeters are in a meter is a 100 centimeters to 1 meter, then let's write a ratio equal to 1. So 1 equals. That represents the relationship between meters and centimeters. And actually, I'm going to write 2. So the first I'm going to write is that 100 centimeters is the same length as 1 meter. And literally because of length, this length of 100 centimeters is the same as this length. So when you divide them because of a fraction, the result is 1. But we could also flip this fraction and put meters on the top and centimeters on the bottom. These three values are all the same. They're all equivalent because we're talking about unit length, and so 100 centimeters is the same as 1 meter, and therefore if we switch that fraction around, it's still the same, so it's still actually equivalent. Therefore, I wrote, well, 2 ratios. Use the ratio you wrote in question 2 to convert 520 centimeters to meters. Here's what you do. You start with what you have, you multiply by a conversion, and what you get is what you want. So if what I have is centimeters, and what I want is meters, then I'm going to put the conversion ratio so that it's going to put centimeters on the bottom. Because if what I have in centimeters needs to be reduced or canceled, and I want meters to be left, then I'm going to put 1 meter over 100 centimeters. That's what goes in this blank. 520 centimeters goes in this blank. And then when I multiply, I'm going to get meters, which actually 520 times 1 divided by 100. When you divide by 100, this decimal, there wasn't one at the beginning, but there's always decimals at the end of unit numbers. You'd move the decimal 2 spaces. That's what dividing by 100 looks like. But let's just confirm it. Hey Siri, what's 520 divided by 100?
520 divided by 100 is 5.2.
Okay. You know, in fact, if you take chemistry, when you take chemistry, or at some point along the way in your physical science classes, your teacher might teach you this method. You're going to draw a line, because all of these unit conversions are based upon fractions. And if what we have is 520 centimeters, then I'm going to put 100 centimeters on the bottom. And then I'm going to put what is equivalent to 100 centimeters on top, and then that'll close that fraction. And now we multiply straight across. Technically, there's a 1 there, so then I multiply straight across. The good thing about this method, and it shows up here in the equation form, is centimeters and centimeters will cancel, just like they did here. We'll be left with meters. Therefore, our answer in meters will be what we get when we do 520 times 1 divided by 1 times 100, which is still 5.2. You know, we really do need to get more into the process of unit analysis when we do our solving real world problems. And most of our similar right triangles are going to be based upon like measurements that we can obtain in the real world. So expect most of your answers to have some sort of unit measurement at the end of them, whether it's meters or centimeters or feet, miles, yards, etc. Thanks for watching this video. This has been page 535. Page 536 is next, and we are starting one of the most crucial geometry concepts for your high school career. So, thanks for watching. Thanks for sticking around all the way to the end. Appreciate you, and I will see you in the next episode.